Hello viewers. So இந்த வீடியோல நம்ம parallel resonanceல solved problems பத்தி detailed பார்ப்போம். So for the given problem, given the parallel network in the figure composed of ideal elements, determine the resonance frequency, find the total impedance at resonance, calculate the quality factor, bandwidth, cutoff frequencies F1 and F2 of the system, find the voltage VC at resonance, determine the currents IL, IC at resonance. So இதுதான் வந்து இப்ப நம்ம calculate பண்ண போறோம். So first வந்து நான் ரெசோனன்ஸ் ஃப்ரீக்வன்சி கால்குலேட் பண்ணணும். இது எல்லாமே வந்து எனக்கு ஐடியல் அப்படின்னு சொல்லிட்டாங்க. சரிங்களா? ஸோ ஐடியல் எலிமெண்டா இருக்கக்குள்ள என்னுடைய பேரல் ரெசோனன்ஸ் ஃப்ரீக்வன்சி இஸ் ஆல்மோஸ்ட் ஈக்குவல் டு எஃப்எஸ். ஸோ எஃப்எஸ்க்கு எனக்கு ஃபார்முலா தெரியும், விச் இஸ் நத்திங் பட் 1 டிவைட் பை 2 பை ஸ்கொயர் ரூட் ஆஃப் எல் இன்டூ சி. அப்போ தேர்ஃபோர் இந்த வேல்யூஸ் இதுல சப்ஸ்டியூட் பண்ணா எனக்கு என்ன கிடைக்குன்னா 2 பை ஸ்கொயர் ரூட் ஆஃப் த வேல்யூ ஆஃப் எல் இஸ் 1 மில்லி ஹென்ரி, 1 into 10 to the power of minus 3 into it is 1 microfarad, 1 into 10 to the power of minus 6. If I simplify this, so 2 shift pi into square root of, it is nothing but 10 to the power of minus 9. So this is the denominator value. If I take inverse, so this is the corresponding frequency, 5032.92. 5032.92 ஹெர்ட்ஸ். ஸோ இதுதான் வந்து என்னுடைய ரெசோனன்ஸ் ஃப்ரீக்வன்சி. இப்போ நெக்ஸ்ட் என்ன கேட்டிருக்காங்க அப்படின்னா, ஸோ ஃபைண்ட் த டோட்டல் இம்பிடன்ஸ். சரிங்களா? இதோட வேல்யூ என்ன அப்படிங்கறத கேட்டிருக்கிறாங்க. ஸோ ஃபர்ஸ்ட் ஆஃப் ஆல் ஐ வாண்ட் டு ஃபைண்ட் அவுட் த வேல்யூ ஆஃப் எக்ஸ்எல். எக்ஸ்எல் which is equal to, it is nothing but 2 pi fs into m. Here fs which is equal to fp, so that I take it is fs 2 pi fs into l, not m, it is l. So therefore 2 pi into 5032.92 into the value of inductance is 1 millihenry, so 1 into 10 to the power of minus 3. If I simplify this, so this is the frequency value, it is multiplied by 2 pi into 10 to the power of minus 3. So it is nothing but 31.62. So the value of XL which is equal to 31.62 ohm. Now I want to find out the value of XC. Okay, so here itself they give at resonance. So therefore at resonance XC which is equal to XL, so that the value of XC which is equal to 31.62 ohm. And moreover the total impedance which is equal to R square plus XL minus XC the whole square over the square root. So we know that at resonance condition this term is equal to 0. So therefore my total impedance is equal to R. So therefore my total impedance ZT which is equal to the value of resistance is 10 kilo ohm. So this is the overall impedance. So next one, calculate the quality factor. So we know that the quality factor of the parallel circuit which is equal to R divided by XL. Here the value of R which is equal to 10,000 divided by the value of XL which is equal to 31.62. If I simplify this, it is 10,000 divided by 31.62. It is 316.25. So next I want to find out the value of bandwidth. So bandwidth, the formula for bandwidth is Fs divided by Qs, the quality factor. Here the resonance frequency which is equal to 5032.92 divided by 316.25. If I simplify this, So 5032.92 divided by answer, which is equal to around 15.91 hertz. So therefore the bandwidth is 15.91 hertz. So next என்ன கேட்டிருக்காங்க அப்படின்னா my cutoff frequencies கேட்டிருக்காங்க f1. So we know that the formula for f1 is 1 divided by 4 pi c into 1 by r minus square root of 1 by r square plus 4c divided by L. Now you substitute the values of capacitance C or L, you get the value of F1. Similarly, to find out the value of F2, which is 1 divided by 4 pi C into 1 by R minus, it is plus here, square root of 1 divided by R square plus 4C divided by L, which is equal to. So this is the value of F2 whenever you substitute the values and simplify. So take it as a homework. There is another way to find out the value of F1, F2. And we know that for the parallel resonant circuit, the impedance should be very high. Okay, the curve should be like this. So this is the cutoff frequencies F1 and this is cutoff frequency F2. And we know that this curve is symmetrical. Okay, so therefore the difference between these two frequency is called as bandwidth. This midpoint frequency is taken as Fs. So it is an ideal case. So that my frequency is Fs. So therefore the distance between these 2 points, is equal to bandwidth divided by 2. So that from this diagram it is very well clear my F1, which is equal to Fs minus bandwidth divided by 2. And similarly my F2, which is equal to my resonance frequency plus bandwidth divided by 2. And we know the value of Fs, which is nothing but 5032.92 minus the value of bandwidth is 15.91 divided by 2. And similarly F2, which is equal to 5032.92 plus 15.91 divided by 2. So this is the value of F1 and F2. And we know that it is the value of bandwidth. So this is bandwidth divided by 2. So 5032.92 plus answer, which is equal to, sorry, minus answer, which is equal to almost 5024.9 hertz. And similarly, if you add this, so 15.91 divided by 2 and 5032.92 plus answer, it is 5040.875. So here in some cases I take some round off value. ஒரு சில கேசஸ்ல நான் ரவுண்ட் ஆஃப் பண்ணிருக்க மாட்டேன், அதனால அந்த ஆன்சர் should be somewhat deviation is there, but this is the concept. But for getting the exact answer, just you round off the value from the decimal, you take minimum 4 digit, so get the answer very closely. Okay, and the final one is find the voltage Vc at resonance. So it is very simple. At resonance condition, we know that XL, which is equal to Xc. Here all the three elements are connected. So at resonance only resistive element is present, so that the entire current flow through this resistance is equal to this I, which is equal to 10 milliampere. ஏன்னா மொத்த at resonance conditionsல XL Xc cancel ஆயிரும், so that மொத்த current the resistance வழியா தான் flow ஆகும். சரிங்களா? இப்போ இந்த 3 எலிமெண்ட்மே எனக்கு பேரலா கனெக்ட் ஆயிருக்கிறதுனால, விஆர் விச் இஸ் ஈக்குவல் டு விசி அப்படின்னு எடுத்துக்கலாம். விச் இஸ் ஈக்குவல் டு ஐ இன்டு ஆர்எஸ். ஸோ ஐயோட வேல்யூ வந்து எவ்வளோன்னு பார்த்தோம்னா 10 milliamps into 10 kilo ohm. If I multiply this, milli and kilo cancel, 10 into 10, 100. Therefore, the voltage across the capacitor is equal to 100 volt. The next one is determine the currents IL and IC at resonance. It is very simple. IL which is equal to, we know that these elements are connected in parallel. So therefore IL which is equal to V divided by XL. Here V is equal to VR or VC, whatever it is you take. Here it is 100 volt divided by the value of XL. What we derived here is, it is 31.62. Now you substitute the values of 31.62 here. Now I simplify this. So 100 divided by 31.62. It is 3.16 ampere. 3.16 ampere. And similarly, IC value is similar to this value. Why? Because the XL and XC both are equal. So that the value of IC is also 3.16 ampere. I hope this problem is very well clear to you. Thank you.